Hey everybody, welcome to today's Kubernetes masterclass. We have persistent storage in Kubernetes and Project Longhorn. Really excited to have you all on the line. We have a huge number of registrants today, so expect it to be a really raucous crowd and a lot to go over. We have about 90 minutes scheduled for this. We can go long if we need to, but I want to let you all know that this session is being recorded and you will get the recording and the slides after the training. So if for whatever reason you need to jump off, go to another meeting or what have you, you'll be able to revisit this presentation later. So with that, I want to introduce myself and my colleague. Let's see, there we go. Oops, going one too far. Okay, so my name is Matthew Shear. I'm marketing manager here at Rancher. Included my Twitter and email address. Please reach out to me if you need any resources, or you're looking for the recording, or you didn't get it in your email, or have other questions that you want answered. I'll be your point of contact. And our presenter on the line is Sheng. Sheng, are you there?
Yes. Hi, everybody.
All right. Fantastic. Well, I'll let Sheng do a little more introductions as we go on later, and he takes control of the presentation. Just a couple other housekeeping items before we really get started. We said try to keep the presentation 40-45 minutes. I'm sure we will go along. Like I said, we have 90 minutes scheduled, and we do that because this tends to be very responsive to what you all want to learn about, and there's always a lot of questions. So please do ask. This is meant to be not so much a webinar as more a class, and so we want to be here to answer your questions and respond to what you want to learn about. So there is a really cool questions feature in GoToWebinar. You see the questions tab, and you can ask your questions there. If for whatever reason you want your question to be private and just answered in a private channel, just mark it so, let us know. Otherwise, we will answer it for the benefit of everyone. And we'll take pauses during the presentation to answer a couple questions, and then we usually have a lot of questions at the end as well. And as I mentioned, the session is recorded. We will post it on YouTube. We have a ton of other webinars, online meetups, classes on YouTube on a ton of different topics. So please check those out. They're all free and publicly available. We put on our online meetups once or twice a month, and these master classes 3 to 4 times a month, and then our intro trainings every week. So there is just a ton of material to watch. Get some popcorn, ignore Netflix, and check out the Rancher YouTube. This is a thriving community going through these open source technologies, Kubernetes and Rancher. So check out slack.rancher.io. I'm sure many of you are already on there. It's thousands of members and hundreds of people engaging every day. And this series has its own channel, Pound Masterclass. If there's questions or files that we need to add there, then we will do so. And of course, there will be other conversation about storage on other channels as well that you can check out.
Sorry, just one word about we have a Longhorn storage channels for the people who are interested in Longhorn specifically, and it's also in the Rancher Slack channel. It's also in the Rancher user Slack. Perfect,
awesome. Yeah, we can include that channel name in the follow-up emails too, if you guys forget it. And finally, there are other classes coming up, so please check those out almost every Tuesday for the remainder of the month and through the summer. We'll talk about some DevOps culture and workflows next week, and then database recovery, and then disaster recovery as well. So there's a ton of good stuff, and there are other sessions we are adding to the calendar as well. I haven't just posted them. I'll try to do that after this training, so please check back in later. Okay, now that is all out of the way, please take it over. Sheng, get a heart of our material today.
Sure. Okay, so I think, Matthew, you need to give me your... Okay. Hey, Matthew, can you give me the keyboard and mouse control?
Sure. Let me see how to do that.
Okay, I think I got it. Yeah. All right. Okay. So everyone, welcome to the webinar. And my name is Sheng Yang. I'm from Rancher Labs. For the last few years, I've been working on this storage project of Rancher called Longhorn. And today I will talk about the persistent storage concepts in the Kubernetes. And I will clarify some very easy to confusion concepts like PV and PVC, and RWO versus RWX, which is read write once versus read write many. And some scenario, you're probably going to use deployments versus StatefulSet, and all this basic storage concept in the Kubernetes. And also, I will give an introduction, and if you have joined the Longhorn sessions before, and also an update for the Longhorn project. Sorry. All right. So during this class, feel free to ask questions anytime, and I will try the best to answer it. And we can also follow up offline if you want. And so let's get started. So for the persistent storage in Kubernetes is not really an easy object as it seems, and many people familiar with Kubernetes, familiar with the concepts as pod and the deployments and something like load balance. This is kind of more easier to understand. But for the persistent volume part, like concept like PV and PVC, storage class, provisioner, and volume, there are many related, but not exactly the same concept in the storage area in the Kubernetes, and confuse a lot of people. So here I will give a brief introduction on what these concepts are and what they used for, and how they come to this state, like you see all these concepts involving in the Kubernetes. So the first basic concept for the persistent storage in Kubernetes is persistent volume. And as you can remember that persistent volume, or what we call the PV, is just a piece of storage can be used for the Kubernetes, in fact, that's just Kubernetes pods. So for example, if you imagine that you have a hard drive and your container is like a machine, and the PV is just that piece of hard drive. The hard drive does not necessarily already connect to the machine. So how do you connect this hard drive to the machine is using the persistent volume claim. So the persistent volume claim is in fact a request for the PV, and whenever Kubernetes see the PVC, and he will try to find a PV matching for that PVC, mostly based on what size you ask for. So for example, if you want to ask a volume size of 10 gigabit, and what's available right now as PV is probably 100 gigabit, but the Kubernetes may think that's probably the best fit at the moment. So they're going to bound that PVC with that 100 gigabit PV, and then you can use that PV inside your Kubernetes pod. The next concept is the storage class. The storage class itself is in fact just a connection of PV. They share the same type of properties, like how this PV being provisioned, and how many IOPS they're supposed to handle, something like that. And in the Kubernetes, storage class has two ways to work. One is they function as a tag. For example, when you have a PVC and you're asking for specific storage class, and the Kubernetes will check the PV with the matching storage class, and only able to match those PVs outside any other PVs with different storage class. They only match the PV with the same storage class as you are specified in the PVC. Another way of another storage class functionality is to deal with the provisioner. And the provisioner is a relatively new concept, and is used to provision PV dynamically. And we'll talk about more of that later. Finally, there's another concept which is very confusing. It's called volume. You can see that we have PV and the PVC both with has something to do with the volume, But in the Kubernetes, the volume itself is only referred to the storage used by the pod. It's in fact just a field in the pod spec. The volume can be a PVC, but it can also be something like AWS EBS or Azure File, Azure Disk, Google Persistent Disk, and this kind of any built-in storage vendors data source can be used as the volume. And the volume normally was referring to as present in the pod as a directory. For example, you can have by using a volume, you can have a directory backed by the, say, AWS EBS or by the Longhorn volume, and this by the Longhorn, and this kind of just present that volume as a directory, which your application can directly access into the pod. The volume concept doesn't exist outside the pod. Okay, so that's just a brief introduction. Let's take a look at how things normally work. So before storage class was introduced, this probably in the before Kubernetes 1.6 or 1.7, the persistent storage in Kubernetes looks like this. So the Kubernetes, if you want to use persistent storage, the admin can have to pre-allocate a few PVs. And this PVs has kind of different various size, like 100 gigabits, 10 gigabits, this kind of, and other properties like IOPS, throughput, define the QoS, this kind of things. And the PVC, as you can see here, as I said, is the request for the certain PV, and normally they just match by the size. And of course, you can add more limitation later, more parameter for matching later. But the thing is that you can just think that one PVC, they're going to only match to the one PV. And how this works. So the pod, you can see that we have 3 pods here. One pod have 2 volumes, and another 2 pods, each one has 1 volume. And the pods, when pod want to use this volume, and the volume will refer to the PVC. As I said, PVC will represent a request for the PV. So the Kubernetes see the PVC and see the PVC using by the pod, and the Kubernetes will try to match the PVC to the existing PV, which is allocated by the admin. And the PV and the PVC will bonded at this point. And the bonded is the word using the Kubernetes storage. And now you can see that the PV and the PVC is always 1-to-1 bond. And one common misconception of the PV is more like a storage pool, but in fact it's not. PV is only one piece of storage, and the storage pool is something like you can carve out. So the PV is more like the already carved out storage, which only going to be bounded by one PVC and going to be represented by one volume and using the one pod. So that is how things was going before the storage class was introduced. As you can see that in this model, we do have a problem that admin have to manually pre-allocate PV before the consumer before they even know who the consumer is, like just which pod going to use it and how big the pod need. So that is basically make admin is very cumbersome position. Like you have to predict the necessary, and also it's always going to have some waste if you allocate PV is bigger than what you need as you're defining the PVC. So that is why the storage class and the provisioner was introduced. So after storage class was introduced, which currently is the recommended way to manage persistent storage, and as you can see that the storage class with provisioner will be in the central place, and we no longer have pre-allocated PVs available. So how things work now? So still, we have those 3 pods, and each has a few volumes, and the volume refer to the PVC. And whenever the pod was starting, and the Kubernetes will observe that this PVC was asking for a certain storage class, and that storage class has a provisioner. So Kubernetes didn't find any existing PV matching, and then the PV and the Kubernetes were using the provisioner to provision a new PV dynamically according to what the PVC was asking. And this PV was just newly created. We are just going to be matched with the PVC's requirement for that piece of storage exactly. So there will be no waste, and you are not going to involve any effort by the admin to allocate the PV manually. So later, after PV was allocated, PVC will automatically bound to it, and that piece of storage software, the storage will be used by the pod as in the volume, and most likely just mounted one directory inside the pod and used by it. So that's the basic concept of the PV, PVC volume, and why we need a storage class and a provisioner. So is there any questions?
So far, no. You're good. Just people paying attention.
Okay. All right. So there are two access modes you probably see when you look into PV. One is called read-write once, another one is called read-write many. But in fact, there's a third mode which is less commonly known, which is called read-only many. Oh, in fact, I have just a typo here. PV has 3 access modes, not 2. So this one major difference between the read-write once and the read-write many type storage, because the read-write once type storage can only be read and write on a single node at any given time. So it's normally a high performance block devices. And the example for that is AWS EBS, Azure Disk, Google Persistent Disk, Ceph RBD, and Longhorn. All the storage solutions only provides the block device for you to use, and the block device can only be used if you want to read-write access to it. They can only be attached to a single node, and you have to be on that node to read and write for it. And on the other side, the read-write many type storage can be read-write on a multiple node at the same time. That's normally a distributed file system, like AWS EFS, NFS, GlassFS, CephFS. So the reason why is if you know a little bit more about the file system and the block storage block device in the Linux, the file system sits on top of block devices. So when the file system was mounted, which is normally how we use a block device, any read-write must go through the file system, and file system will have a cache and have some optimized read-write for that underlying block device. So some of the data, some of the read-write access may not hit the block device at all. And the file system doesn't expect block device to change. So assuming if you mount one block device on 2 different nodes, because they are not sharing the same file system, so each node can make changes in the underlying block device without, say, node 2 can make change in the block device without the node 1's file system knowing. And the node 1's file system will immediately see that, okay, something unexpected happened on the block device. It will assume that it's corrupted. So that's the basic concept why we have this read-write once and read-write many differentiation. And one is only for the block device, another one is more for the file system. And this introduced a little bit more complex later, like just how you're going to choose to deploy your applications. I think people is very familiar with the concept of deployment, and later to accommodate more stateful applications, Kubernetes introduced a concept of a semantic called statefulSet. So in the current design of deployment, you have multiple pods. You can scale up, scale down the pods. Those are very common use with stateless applications. But the problem with the deployments is that the pods in the one deployment share the same volume. And this doesn't matter which node the pod running on, which of course you normally want your deployments, but the pod to be spread on the different nodes. So if one node goes down, you can still have a providing service through the other nodes, right? But the thing is, if they are sharing the same, the pods sharing the same storage, it's not possible for read-write once type storage to do that, because as I said, read-write once type storage can only be read-write on one node. So if you are using deployment and you want to store some state in your scalable in the persistent way, it's better for you to use read-write many type storage. But normally, even if that's the case, you will not want to have multiple. Normally, you will not want to have multiple applications write into, say, same directory and modify the same file, because as I know, the locking mechanism is not really that great in the distributed file system, and many of them, if you are writing the same file directly, it still can cause corruption. It's just like the case with the block devices. Sometimes that is up leave to your for your applications to handle. So on the other side, on the other hand, the stateful set in each pod in the stateful set can have one volume. So the volume claim template supports this. So you can define a volume claim template and make it, and Kubernetes will automatically generate generate volumes for any when you scales up, and they will just detach the volumes when you scales down. So in this way, each pod have access to one volume, and you can use more high performance read-write once type storage with the stateful set. I see there are questions.
Actually, Sheng, there's only been one question, which has been just a request for the recording afterward. So, and just as a message to everyone. Yeah.
Okay.
Yeah, just as a message to everyone.
I don't know what's that.
Oh, cool. Yeah. If anybody does have a question, please ask. Yeah. But keep going.
Yeah, feel free to ask the questions. If anything you want to explain more clearly, or you want some examples, just let me know. All right. So the stateful set can easily be scaled horizontally, and because you can have more volumes created automatically for you, and it's easier for the stateful applications. But you don't need to use stateful set just because your application is stateful, and you can still use the deployment if you say you make sure that the scale is 1, or if you make sure that the application able to handle the read-write into the same storage correctly, and that's also fine. All right, so no questions?
Oh, one question did just come in, which is, can you explain a little more about volume claim template?
Oh, so the volume claim template is more like saying that you define a name for this volume claim template, and you say that, okay, so I want to use which storage class for it. For example, you want to use Longhorn for it, and whenever for example, if you have originally one pod and the volume claim, you can using that volume claim template to create one volume for that, and that volume will probably called like if you code say pod name dash volume claim template name dash 0, and if you scale up the stateful set into 2, another PVC just volume claim will be created. Say like this, just pod name dash volume claim name dash 1, and the number will keep increasing if you are scaling up your stateful set. And as I mentioned before, that this in fact this only works if you have it's more likely it works better, much better, if you have storage class and the provisioner set it up, because each new PVC, just PVC generated from the volume claim template, will automatically provision a new volume for your applications. So that is how you all connect up. And when you scale down, for example, you previously have 3 PVC, now you 3 pods, and they have 3 PVCs, and you want to just scale down to back to 2. Well, then the Kubernetes will just remove 1 pod from your stateful set, but the PVC will still be there, and the PV will still be there. So the next time we scale up, they will, because you can see that every time we scale down, scale up, the surface of that pod of that volume PVC are fixed. So the next one you scale up, you're still going to have like a PVC-2, and you are going to use the same volume as before, as your previously scales down. All right,
awesome.
Does that explain your question?
Yeah, that's great. Thank you. And if you have a follow-up, please. Oh, he says yes. There are 2 more questions right on this topic that just came in, so let's answer them quickly, and then we can keep going. This is from Raphael, who says, which one, a deployment versus a stateful set, would you use for scaling out a Postgres SQL database with multiple read-only volumes in separate remote data centers?
With multiple read-only volumes, if you have a read-only volumes, this is normally okay. So that I need to check if the Postgres is horizontal, is vertical scale or horizontal scale. So basically, yeah. So basically means if you scale by, say, that increase your CPU or memory, or you scale by just across the different nodes.
Cool. Okay. Well, Raphael, if you could let us know the details, and then we can answer it. So let's do this one last one.
Yeah, I think Postgres is probably horizontal scale. So if you want to do the multiple read-only, I think it's fine if you use. Yeah, I think you should use the StatefulSet, because if you want to have a performance, you better go with the block devices. And some block devices does support read-only manning, and even that you can, if you use that, you can have the block device spread out into different nodes. But as long as it's read-only, the integrity of the data is fine. In fact, the deployment, let's see about deployments. Yeah, I think deployments is fine too. It's because it's read-only manning. It doesn't really matter here. Yeah.
Okay, cool. Thank you. There's a couple more questions that have come in. Why don't we you keep going, and then at the next break we can take more questions.
Okay. So in fact, for the next slide, I'm going to talk about Longhorn. So I can just take questions now for the basic concept.
Oh, great. Okay, so this next one is from Edgar's, who says, how do you sync data between volumes created by volume claim template?
That is your application's responsibility. Like, just say you have a horizontally scaled database, and the application itself need to handle the synchronization and the synchronization for the data. So the application itself need to have some protocol between them and make sure that the data is consistent. But that is not. But each of the block, the volume itself is separate. But the application need to handle that, how to make them consistent and present a unified view to the outside users. That's the application's responsibility to do that.
Okay, cool. Thank you. Okay, here's the next one. This is from Brennan, who asks, is it possible to use a deployment and a volume with RWO type storage? When I used this configuration in the past, I was unable to do a rolling deploy even when I had only one deployment replica. due to a second pod being spun up before the first pod had released its claim.
Yeah, so you can do that. There's one thing called the role upgrade policy. You can specify that to be a delete before spinning up the new one, and then you can use that. Because normally the rolling upgrade is more like you spin up a new pod, and then after new pod is coming up, you shut down the old one. So that case, you won't work with the read-write ones with the deployment, even you have only one pod. But after you specify the rolling upgrade policy, like just delete the old one first and then start a new one, it will work.
Awesome, thank you. Okay, here's the next one. This is from Anil, who asks, suppose a container crashes, what will the time be required to attach it to another pod?
It depends on the storage. So there are many factors here. The first one is how long for the Kubernetes to detect the storage was the pod was crashed. So for example, if you crash just because of storage, the container itself crashed, or pod itself crashed, Kubernetes will detect it very soon. And the Kubernetes, if you're using deployment, will start a pod on another node immediately. But in that case, it's less known factor is on the StatefulSet. Kubernetes will not spin up new pod automatically. That's something we are working with upstream, and we'll try to fix that. Because personally, I don't think that makes sense. People will expect deployment and StatefulSet act the same way. But the consideration of Kubernetes currently is that they want to maintain the pod a stable identity if they are in the StatefulSet. But I do think it makes more sense for the StatefulSet to kill the to delete the failed pod and start another pod using the same warning. And if you have a node crash, the things will become slower, much slower, in fact, and you're probably going to take around 6 to 11 minutes basically the sequence is like Kubernetes will take 1 minute to notice the node is down, another 5 minutes to to determine that the pod is gone, is unresponsible, and another probably 5 minutes to try to detach if you are using read-write once type storage. So that is also something we're aiming to improve with the Kubernetes upstream.
Thank you.
But but in the ideal case, if you have a deployment and you have for the disaster recovery, you have deployment, you have read-write mining type storage, and is owning the pod crashed, the Kubernetes should respond in a couple of minutes and spin up the new pod.
Thank you. Okay, cool. Sheng, here's the last one, and then we can get to the Longhorn demo. And this is a follow-up from Raphael, who had asked which one, deployment versus StatefulSet, would you use for scaling out the Postgres database? And he says, thank you for your first answer. It's a complex topic because you also want to factor in the fact that the volume needs to be copied between data centers on instantiation because WAL is too slow.
Yeah, I think that's a really complex problems. And the thing is, so there's one thing I will demo on the Longhorn later. But if you are going to deploy your PostgreSQL across data centers, yeah, I need to check more on that. How this deployment is going to work, because normally it's not synchronized. It will be asynchronized, and normally you don't have one Kubernetes cluster across data center, right? So we can follow up on this offline. I need to know more about the scenario, how we're going to use and how we deploy it before providing a good answer, Brad.
Yeah. Okay, makes sense. All right, thank you. That was the last question.
Okay, so let's talk about Longhorn. And also feel free to ask me questions about the Kubernetes concept. And no worry about that. And let's talk about Longhorn. So Longhorn is a distributed block storage software we have been working on for the last few years, and it's designed for the Kubernetes, and it's designed to be very simple. And you can add your persistent storage support to any Kubernetes clusters just using one line of command. And also, Longhorn supports installation using Helm chart and the Rancher app. And you can get Longhorn at this the link I provide here, the github.com/longhorn/longhorn. And also we have a website building, and it should be available soon. Okay, so the latest release for Longhorn is 0.5.0. As I mentioned, Longhorn is the enterprise-grade distributed block storage software for Kubernetes, and we support volume snapshot and volume backup and restore. The difference between the snapshot and the backup is the snapshot happens inside your Kubernetes cluster, but for the building backup function, we allow you to back up your volume to the outside of cluster, like a S3 or S3 compatible API object stores or NFS server. So even something happens to your volume or something happened to your cluster, you still have a way to restore your precious data. That's another thing of Longhorn, which makes it outstanding, is this early stage, we already support a live upgrade of Longhorn software without impacting the running volumes. Of course, we cannot guarantee that 100% time it can be upgraded without impacting running volumes, because it's a system level, low level technologies, and sometimes we need to fix some part, which is probably need you to do offline upgrade. But we do majority of time live upgrade is available. And Longhorn also support cross-cluster disaster recovery with defined RTO and RPO. RTO is the recovery time object. RPO is recovery point object, which basically define that how long it's going to do the recovery and the data will be for after you recovered. Sorry, one moment. Okay, I'm back. Sorry, something interrupted me. All right. So I was talking about the RTO and RPO. With this feature, you can have two clusters. One is your main running cluster, another one is a backup. We can automatically continuously shipping the data from your main clusters for your volumes to your backup cluster. So if you have a disaster failover needed to happen, it can happen very quickly with this feature. And the Longhorn also provides intuitive UI for your use, and we will demonstrate that later. And one-click installation, since we're built for Kubernetes. And more features are coming, like QoS, volume resizing, real-time performance monitoring, etc. All right, so let's take a look at brief at the Longhorn architecture. So the Longhorn has two major parts. One is we call the engine. Another one is called manager. The engine acts as the data panel for Longhorn. So for example, here we have two nodes. Each of them have a few hard drive and the RAM and CPU. And when one Kubernetes pod asking for a volume, and we will start two replicas and point to two different nodes, because if one node goes down, we still have one running and providing the access to the volume. So after two replicas was created, we are going to have an engine process engine controller coming up and connects to the replicas and providing the block device to the pod, and in the end will be presented as a directory inside the pod for the pod to use. So you can see that this this architecture is very simple. But what if we have more pods, and then we just have more replicas and engines to provide the service for the pod? So as you can see, the data paths of each volume are separated. So if one volume goes down, it's not going to impact any other volumes because they're basically the data path is separate and not crossing and sharing, right? So, but now we have this bunch of engine and the replicas, that seems many of them, that how we are going to manage them. They are going to orchestrate by the Kubernetes. So on this slide, I will talk a little bit more on how we manage the engine replicas through the Kubernetes. So imagine you have a Kubernetes cluster, and whenever a pod wants to have a Longhorn volume, the Kubernetes cluster will talk to the Longhorn CSI plugin through the CSI API. So a little bit more about the container storage interface we call CSI. It's the standard which the Kubernetes, the Mesosphere, and the Docker reach in consensus and created this standard interface for the cloud native orchestrators and make them they have a spec on the website, and Kubernetes is going to use CSI and migrate everything to CSI in the future. So the CSI plugin in here will talk to the Longhorn manager through the Longhorn API, and the Longhorn manager is the one going to orchestrate all the volumes. So Longhorn manager is written in a Kubernetes operator, or you call it Kubernetes controller pattern. The Longhorn manager, every time when they see a new request coming for creating a volume, they will talk to the Kubernetes API server and create object there. And the Longhorn manager also has a bunch of controller running. They will observe and monitoring the status of objects inside the Kubernetes API server. So they see a new volume was created, new volume object created, and this controller will going to create a new real volume, like create engine replicas for their volumes. So if you have multiple volume created, the controllers inside the Longhorn manager will going to create multiple engine replicas, and that's how we implement the Longhorn volumes for the Kubernetes. Another entry point for the Longhorn manager is the Longhorn UI. So the Longhorn UI will also talk to the Longhorn manager using the Longhorn API, and the Longhorn UI will be a complement of the Kubernetes. Normally, the Kubernetes handles the volume creation deletion because they know the pods who initiate the request. And the Longhorn UI, you can do a bunch of things like monitoring and creating snapshot and the backup and managing them in the Longhorn UI. We'll see that in the demo in a few minutes. All right, any questions regarding the concept of Longhorn?
Yes, there are. There's several questions. Okay, here, let's see. So Boris asks, he says, Portworx uses etcd to store service data. What does Longhorn use?
Oh yeah, Longhorn use in fact, in the end, Longhorn also use etcd, but Longhorn is used as a part of Kubernetes. We don't require user to set up an extra etcd store for the Longhorn, because you know that etcd operation is not really an easy thing. So we don't want to use it to spend extra effort to do that. So we just use the Kubernetes API server as using CRD, customer resource definition, to store our service data. But in the end, that data will be stored in the Kubernetes etcd cluster.
Okay, cool, thank you. Okay, here's the next one from Herman, who asks, how many engine pods per volume? Because I sometimes see more engine pods than nodes for a volume.
How many engine pods per volume? Okay, so currently you have, we go with the default setup of 3 replicas, you have 1 engine pod and the 3 replica pod per volume. But that is something we are working on in the next release, because we know that there's a pod limitation on the Kubernetes side, which is 110 per pod, 110 pods per node. So in the next release, we are going to share share some pods between the engines and the volumes and make sure that we're not going to run through that limitation.
Okay, great. Let's see. Trying to find another one. Does Longhorn support cloning? I'm interested in using the copy on write COW for the clone.
Currently, Longhorn doesn't support cloning, but again, I know the Kubernetes have the feature for that, but we haven't started working on that yet. I don't believe that will be hard to do.
Okay, cool. Here's the next one. Is data encrypted in transit and stored encrypted?
No, the data is basically available to the people who have the root access to the node. And regarding the data, if it's encrypted in the transit, you can use, because if you use because the Longhorns go through the Kubernetes overlay networking, so if you use Calico for your overlay networking, they already have some encryption protocol in that, so you can just take advantage of that. Yeah, but the data encryption is the one thing where in our roadmap, the first thing we want to do is probably just encrypt the data in the backup store, and later we are thinking about the encryption on the local disk, because in fact the computing cycle using for encryption is normally pretty high. So and we'll see to that.
Cool. Okay. Man, there's a lot of questions. There's a bunch of questions kind of comparing Longhorn to Ceph, Rook, and others. Do you want to take those now, or do you want to go through the demo first?
Yeah, let's go to the demo first. I already used 45 minutes. I'm gonna start that.
Okay, cool.
Okay, let's go to the demo first, and there should be some time during the demo. I can answer those. I can answer more questions. Okay, let me. One moment, allow me to. All right, so you see my screen, right?
Yes, you're good.
Yeah, good. So do I need to make it a little bit bigger?
Yeah, a little bigger is helpful.
Yeah, 150. Yeah, better. Okay, so here I have a rancher set up, and we have 2 demo clusters here. And let's go to how to install Longhorn. In fact, it's very easy. And I just select one project I created before, and I just go click launch. You select apps in the rancher, it's 224, and you click launch, and you find Longhorn, and you click launch. That's it. So the Longhorn will, you know that the apps in the rancher is created using the Helm chart. And here we just automatically perform the installation for Longhorn. And you see that there's 2 parts already being up. There's Longhorn manual and Longhorn UI. Another one is Longhorn driver deployer. It will take a little bit more time because we want to fully automate our installation. So the Longhorn driver deployer is detecting what is the underlying system, what's the version of Kubernetes and other property they need to check, and they're going to deploy the right version of the driver to make sure that it works best with the Kubernetes. So now you see the Longhorn is up. And let's go to you can just click this index here and go to see the UI of the Longhorn. So that's one-click installation. So here you see the dashboard of Longhorn, and on the left side is the volume status, and in the middle is storage, how much you have used and how much reserved, and how much is available. On the right is the status of your node. Down here, you can also see some event log. Longhorn is using Kubernetes event log to transfer information to notify the user. And in the end here, you can see that the current version is the 0.5.0. And if you have any troubles, you can find issues forum or use Slack. And also one part we added is generate support bundle. So if you have any issues, which is probably take a little bit more time to debug, it's welcome if you can generate support bundle, and it will be downloaded as a zip file. You can check it first, and you can send it to us, and we can help you to analyze it. So the next screen I'm going to show you is the nodes. because I haven't done any pre-configuration for this setup yet, but you can see that the Longhorn itself already using they're by default using the storage available on the Kubernetes node, and we are going to use this path and while leave ranch Longhorn as our default place to store the volume data. And in this page, you can schedule, disable schedule, enable schedule for the node and for the disk. And also, if you have more disk can be used by Longhorn, you can mount it as some location on your host and modify this node disk and to use that a new disk for the Longhorn storage use. The next page is the volume, which we haven't done anything yet. And the backup page, we are going to show you what's the backup store looks like, which is the place we store all the backups. So in order to use the backup, we are going to have set the backup target and the credentials, and this one is resigned in the AWS S3. I click save and go back to backup again and see, okay, so this is some backup I made about 1 month ago. So that means the backup store works as expected. So let's go back and try to start using Longhorn. So here, I'm going to demonstrate using Longhorn with WordPress. And so as you can hear, you can find a lot of applications in the Rancher apps. And for the WordPress, we can just enable persistent volume and choose Longhorn as a storage class. And we need to set password correctly. And Longhorn, yeah. Let me double check. Yeah, that's about it. Okay, let's launch. So we can just take a look at the dashboard, and the Longhorn should be able to starting creating the volume by the commands of the WordPress app soon. So you can see that the stew volume is in progress, means they creating and they will be attaching soon. Okay, so attaching. So now you can see that what's the detailed information regarding your volumes using the Kubernetes. The name, the state, the size, there's nothing surprise about that. But also we have features like this one, which show that what's the PV and the PVC name, use this volume inside Kubernetes, and what's the namespaces, and which workload is attached to. You can see that this one is attached to the WordPress workload, and it's the replica set, which basically means this deployment, and what's the pod name, and the pod status is running. And also you can see the information in the MariaDB as well. So this is the feature we take feedback from the user, because normally the information Kubernetes give about the storage vendor is only in the name, and the name is pretty much random, and this is the same as the PV name. So the users want to know that what's the status of volume, and any information may potentially impact any volumes. They want to see that what this volume inside Kubernetes. So that's why we add this feature to make it much easier for the user to know their things. Let's go back to WordPress. So the WordPress is up. I'm hitting the 80 points of WordPress, and you can see that this WordPress using the Longhorn volume, and this works fine. Let's log in. I hope I didn't get, okay, I didn't get password wrong. So let's add a new post, like say Longhorn demo. I can check if this is the way we can check if everything works, right? Everything seems to work as normal. And let's take a look back on I'm switching back to the Rancher, in the Longhorn, and those two volumes. So this is the volume detail page you see, and the left side is the detail of the volume, and the right side, this here is things like we have 3 replicas running for the volume, and you can see what's the node name they're running, and what is the data path they're using, and In fact, this one, for the convenience of user, this is the real path where stored the data on the host. You need to have a root access to this directory to be able to see the data, of course, but if everything goes wrong, as long as you have this one replica and have this information, you can easily recover from any disasters. And we can also take snapshot from here, and we also can create a backup. Backup probably going to take a little bit more time because we are transferring data to the S3. And down here, we do have another feature, which is the recurring snapshot and the backup schedule. So basically means you can schedule when you want your data to be snapshot or backup automatically. And you can, for example, you want a daily backup and ship the backup to the S3 at 3 a.m. every day. So you make sure that if everything happens, you can something you can recover from. Let's see how they works. So I've just created a backup, and for the demo purpose, I'm keeping every minute. I retain the last 5 backup, which basically means I retain the last 5 minutes backup. Okay, and save. And you can see that. So the user asking for to see the reschedule, within the schedule if the schedule is available. So they can check that. They can check for the volumes which doesn't have the schedule enabled and deal with it. So that's why we put this icon here, and click this, you can see that how the schedule, how do we schedule the backup for the volume. And for the same, for the MariaDB volume, we are do the same. So let's create a backup every minute and keep last 5. All right. So you can see that the WordPress one last backup is 2 minutes ago, and the MariaDB one we're going to happen soon. Okay, so any questions?
There are a ton of questions, Sheng.
Okay, yeah.
Do you want to just start diving into these?
Okay, probably let me finish the demo first.
Sure. Okay. Yeah.
Okay, so there's another feature I want to show. Okay, by the way, let's take a look at backup. Okay, you can see that in the backup store, the 2 new volumes shows up, and the last backup is only a few seconds ago. That means that it's automatically backed up by our Longhorn system from the volumes. And what if you have a scenario that you're probably going to you want to have a disaster recovery cluster or backup cluster on the other hand, and just in case this cluster totally goes down. So in this demo 2 environment, we have set up we have already set up a Longhorn, the 0.5.0 release, and we are going to take a look at that one. So as you see that this one is the Longhorn in the new cluster, have no volume in that, and but they're connecting to the same backup store, so I should be able to see the volumes I back up from all the cluster here. So I can create a disaster recovery volume, and that is how we support across cluster disaster recovery. And let me check just one detail. So this is MariaDB. In the next release, we're going to have some more labels to improve the usability here. MySQL, right? And I'm going to attach it. You can just attach to any node, and for the disaster recovery warning to start working. And for this one, we create. So now the disaster recovery volume are being attached, and what is happening in the background is any change in the volumes in the old cluster will be automatically streaming into the S3 as a backup, and then automatically download and incrementally restored in the new cluster. We can prove that. We can prove that by, say, we just change a few things in our website and see how things goes. Yeah, volume demo. So now I create a new post called the DR volume demo, and I can just wait for the old cluster to automatically create backup for this website, and later I will going to recover it from the new cluster. Okay, last backup happens a few minutes ago. Okay, a few seconds ago. Okay, so let's wait a little bit and make sure that data got copied through. Okay, I can answer some questions now.
Okay, great. All right, here this first one comes from Alexi, who asks, how does Longhorn stack up against Ceph, Rook, Gluster, Storage OS, and Portworx?
Okay, so the Rook. Let's talk about the Rook first. Rook is not really a full stack solution. Rook is at the storage operator position, so it's more like take the responsibility of the Longhorn manager. So the original purpose for the Rook is orchestrate Ceph on the Kubernetes cluster. I think Rook did it well, but there's just some problem with Ceph. Is many things we heard from past experience with from the customer is Ceph is very hard to maintain. You have to understand crash. You have to understand how the mechanism works, and otherwise you running the risk have two blocks of your data on the same landed on the same disk, and if that same disk is gone, your data will be lost. So to us, one of the motivations creating Longhorn is because, well, we know that open source solutions Ceph is really regarding of the gold standard, but we do think Ceph is way too complex to operate, and we should be able to have a better solution by providing a simple and the enterprise-grade block storage, just as simple as Longhorn, but still powerful, but not nearly as complex as a Ceph. That's one of our values. Another thing is the performance-wise, Ceph is not really because Ceph using striping and all this technology, which is designed at the time, is really mainly on spinning disk. So it's not really from our perspective, we can take more advantage of the modern SSD and the NVMe, and make it still get very good performance compared to Ceph. So if we can do it simply and with the similar result, we definitely want to do that. So what other topic? What other production?
It was also Rook, Gluster, Storage OS, and Portworx.
Yeah, I talked about the Rook. I don't know much about the Storage OS and the Portworx because they're not open source. They're proprietary, and they sell a solution for that. So compared to that, Longhorn, you can just download it, and as you see that, you can just install in one click. It's much easier. I think I've tried the trial version of Portworx, and I think it takes more resources than Longhorn to install. And but in fact, I don't really know much about storage and the Portworx, so we probably can see that if somebody else want to make a comparison or not.
Sure thing. Okay, here's the next one. So can I set up Longhorn on top of an RKE-based cluster without a separate etcd cluster?
Yes. So that's the purpose of what Longhorn built. We just use the Kubernetes, using Kubernetes CRDs and using Kubernetes as our data store. You don't need to set up another etcd. You have the etcd set up by the RKE for the Kubernetes. That will be enough. Okay, cool. Sorry. Let me finish my last part of my demo. So sure. I definitely think the data should be synced through. And okay, for that sake, I just close the old WordPress, and I'm going to activate this to DR volumes on the new cluster. Activate. Okay, so during this time, I can here in the new demo 2 cluster, I'm going to launch WordPress. Okay, that's one piece of information I needed because the MariaDB is created as a stateful set. As I mentioned before, the naming of the stateful set PVC is pretty strict. You have to follow its naming, otherwise the stateful set won't use it. So we can create PV and PVC directly from the Longhorn UI. And I'm going to use this name as the PVC name for my local volume, and I want to put this on the WordPress namespace. Okay, we can do the same for the WordPress volume. You don't need to be picky about the PVC name for the WordPress volume because that's its deployment. Okay, so 2 PV and PVC should be created. And now this is in the demo 2 cluster. I start another WordPress, and it will be in the WordPress namespace. I need to put the same password here and enable persistent volume and select persistent volume claim. I want to use the same volume like we just activated, right? And the MariaDB password need to be the same. Persistent volume enabled. You see that there's just no option for you to choose your name. That is automatically decided. So we must make sure that the name matches as before. I think that's it. All right, let's go launch it. Okay, in the dashboard, let's take a look. All right, so any other questions? Yeah, we can just wait now.
Sure. Okay, here, this one is from Cheyenne, who asks, is Longhorn only supported in Rancher or other orchestration vendors as well as persistent storage vendors?
Yeah, Longhorn supports any Kubernetes cluster. It's not around in Rancher. You can install Longhorn using Helm chart. You can install Longhorn using YAML. In fact, you can just see this. This is our main web page for now. You can see the installation. You have different options. If you're using Rancher, it will be easier because you can just select the apps and click Longhorn. And the others, otherwise, you can use this kube control command line to install Longhorn or using Helm chart. Helm chart is more preferred installation method. But either way, any of this installation method, you can install, you can upgrade, you can uninstall everything. Everything is documented. You don't have to be using Rancher.
Cool, thank you. Okay, this next one is from Janet, who says, it seems like Longhorn is designed to work with commodity hardware as storage. Would you recommend using Longhorn with SAN backends?
Yeah, Longhorn is designed to use with commodity hardware. Sorry, SVN backend? Oh, SAN, okay. Yeah, I think okay, this is a bit of a tricky question because I know people using EBS, and on top of that, they're using Longhorn. The reason is the behavior of Longhorn across all the clusters is identical, but you don't really know that what AWS EBS will do in case like this. For example, one node goes down, right? So, and also if you have very large EBS volumes or SAN volumes, you probably can use Longhorn to cover them out. And it depends on what your SAN solution is. Probably you can use Longhorn's backup, Longhorn backup's capability to handle your backup without using any third-party softwares. There's a bunch of reasons for you to do that, but I think it just depends on what your use case, what your scenario is. I think sometimes it makes sense.
Okay, great. Here's the next one. This is from Boris, who asks, can I use Longhorn with ZFS volumes?
Okay, this depends on the, so let me conclude my demo first. So you can see that this is a new is a demo to on the WordPress, and we see that the post comes up, so the disaster recovery still exists. So let's go back to the question. Sorry, I forgot the question.
Oh, no problem. The question is, this is from Boris. Can I use Longhorn with ZFS volumes?
Oh, that depends on you want to use ZFS as your the file system inside your pod, or you want to use ZFS as the file system, which is used by Longhorn to store the real volume data. The latter is not supported. So because ZFS doesn't support, because if you want to use ZFS to store the Longhorn data, ZFS doesn't support sparse file. ZFS has some limitation on that, and so currently we only support ext4 and XFS for storing the Longhorn data. But if you want to use ZFS as the file system when you up on top of the Longhorn block device, on top of the Longhorn volume, and to be used in the pod, there will be no problem with it. So we support it's just another file system to Longhorn. We don't really care.
Okay, cool. Here's the next one. What about encryption of the volume during snapshots?
Currently the data is not encrypted. The snapshot still happens inside the cluster. It happens just in the replica itself, so it's not really encrypted. After we introduce the encryption feature, everything will be encrypted. If you want to ask about, if you mean to ask about the backup, yeah, the backup currently is also not encrypted, but we put that in the higher priority there. And in the future, we may want user to provide the key for the backup and the restore operation to make sure that we have encrypted the data in the like S3 and OFS, and make sure a user is able to control the accessibility of that data.
Okay, thank you. All right, here's the next one. Does Longhorn take each device for one volume, or can it auto partition physical devices or any other method to allow you to use single physical device to create multiple PV volumes on it?
Oh, so Longhorn is, as you can see here, so each disk, in fact, is just a mounted path on that node, and Longhorn only need to know that what path you have mounted, and of course you can. Longhorn doesn't need to take a whole disk to creating volumes. You can have just in this case, I'm using just the disk on the node, and I have some storage reserved automatically for the rootfs and for the Kubernetes, and other storage Longhorn can use it. So in any case, you can have a single disk mounted at the node, and you can use Longhorn to somehow partition it to different volumes and use for multiple pods and serve as multiple volumes. There's no problem.
Great, thank you. Okay, here's the next one. This is from Scott, who asks, will Longhorn run on Red Hat Atomics OS?
In fact, we haven't looked into that yet. Longhorn currently runs on the Ranch OS, of course. I think we have looked into the CoreOS. I didn't quite remember what the end result is. But the thing is, the distribution is not really a big problem. So if you found this doesn't run on the Atomic OS, you can raise an issue in our GitHub, and we can take a look into it. It's not really that hard. But the one thing about the different OS distributions or the Kubernetes distributions is those paths for the driver, either CSI driver or flex warning driver, always seems to change. Always seems to have a lot of different factors. So that's why we have this driver deployer to implement this smart detection logic. And so if it doesn't run on the Atomic OS, we can just check and see if we can add more in that driver deploy logic and make sure it's just the driver. Make sure the driver works. The driver is the most important part, and other than that, there should be no problem.
Great, thank you, cool. Okay, here's the next one. This is from Frank. Which file system is recommended?
We currently recommend using ext4. If you're talking about the host file system storing Longhorn data, we would recommend ext4. And we have tested XFS also works, but in our current development environment, we all use ext4.
Okay, cool. All right, here's the next one. This is from Herman. Does the next release of Longhorn contain authentication on the admin UI?
Okay, so if you are install Longhorn using Rancher, the authentication is already there, because in order to access this place, access this URL, you need to pass the authentication of Rancher. So that's why, say, if you go here and you click this one, and you can see that it's just the suffix. It's not really exposed just like this. So it's really just behind the Rancher authentication. So this is what we have for the authentication so far. But if you are using YAML or Helm charter installation, you lost this we call the Rancher proxy ability to put Longhorn behind the authentication. And we have an item open for the authentication, and we're going to include that in the future. But for now, just the authentication through Rancher is our current solution.
Okay, great. All right, here's the next one. Does the operation of volume depend on the Longhorn control plane, or is the control plane only used to provision volume, but it's not needed for operations? In other words, will the volume remain operational even if the Longhorn control plane is having issues?
Yeah, that's correct. So the control plane, assuming you're talking about this, okay, sorry. The control plane, I assume you're talking about just Longhorn manager. Yeah. So the Longhorn manager is completely separate from the Longhorn data plane, which is the 3 replicas and the invisible controller connect them together to present your block device. You can totally just uninstall Longhorn and remove everything from the say Longhorn manager, from Longhorn manager perspective, but the existing Longhorn volumes will not get impacted unless you just manually go there and delete all this part, or just manually interrupt it. That's totally separated. That's also how we able to do the one part of that. We can do the upgrade seamlessly, because whenever you have upgrade, for example, you're going to upgrade Longhorn 0.5.0 to the next release, probably next just 0.6.0, the upgrade doesn't impact the data plane, that's the service of Longhorn volume at all. So because that is totally on the control plane part.
Very cool. That's awesome. Thank you. Okay, here's the next one. Is it possible to add replicas to the volume at any time, or only during provisioning of volume?
You can add it.
Awesome. Thank you. Okay.
Yeah. So what happens right now is we call that as on the rebuilding process. So you have a new replica join, and they're going to copy the data from other replicas, and yeah, see, that's the rebuilding. And after that, after rebuilding complete, you have a healthy volume with 4 replicas instead of 3. Yeah.
Great. Okay, here's the next one. Like I said, Sheng, there are a lot of questions, so if you need to drink water, just let me know.
Okay.
So here's the next one. If the pod gets rescheduled to a different node, is it going to attempt to schedule to a node that has a replica, or will it just reschedule to the next available, even if the replica is not local to that node?
Yeah, so there's no locality in Longhorn, so we treat the replica all the same. So you can, the pod can be scheduled to a pod to a node that doesn't have replica. This doesn't really matter for Longhorn now. So the controller will always spin up with the pod in the same node, but the controller will connect to the other node for the replica.
Okay, thank you. Here's the next one. This is from Frank. How can I distinguish between HDD and SSD ALS backends? Two storage classes possible?
Yeah, so in fact, just in the next release, we are going to introduce, in fact, let's bring me to my final slide. Just one moment. Let me go through that final slide. So upcoming next release 0.6.0, this question is regarding to if we are able to distinguish the SSD from SDD, or probably SDD with different IOPS. But in the next release, we're going to support the concept of storage pool. In fact, normally we should call that storage class, but the storage class name is used by Kubernetes, so we call that storage pool. So by using this feature, you're able to label each disk on your node, or even your entire node with one label. And when you create volume, you can select the storage pool or storage class you want to use. For example, you only want this volume to use SSD, or you only want to use it to use HDD. So that's a spinning disk. So that is the support that will be supported in the next release. Another few things we're going to support in the next release is the backup label. You probably remember that when I'm doing the restoration, I need to check back to the older cluster and see that which volume is which. But after we introduce this backup label, the volume itself will be automatically tagged with the related Kubernetes status, just the pod and the PVC, what the original pod is. And also we support manually creating labels for the backup, and you will see that in the backup store, you will see that which volume is for which, and you can more easily to manage that. In the next release, we're going to do we are going to do a new architecture, and as one question also asked before, an engine and the replica pods. Currently, we have multiple pods per volume to serve as the Longhorn volume for the Kubernetes. But in the next release, we are going to have the engine and the replicas run as a process inside separate pods instead of a pod, one pod for each engine or replicas. It's most likely that we have one engine pod, we call it engine manager pod per node, and one replica or multiple replica manager pod per node, and that will greatly reduce the number necessary for the pod necessary for the Longhorn to run in the Kubernetes. So the biggest issue why we have to do this is because we have the pod per node limitation in Kubernetes is about 110. So Kubernetes have an upper limit of 110 pods per node. We cannot exceed that. So it will be easier if we just manage the engine and replica as a process. They're still separated process, and data paths are still not crossed. And another thing is we can now guarantee the resources for the pods because we can allocate the resource and use Kubernetes QoS to allocate, for example, half the CPU for one engine pod, and not half of the CPU, half of the one CPU for the replica pod. So ensure that even the CPU was overloaded on the node, there will still be enough resources for the storage, the Longhorn storage to use. All right, so that's about my slides. Let me go back to our demo, just in case there's something else you want to see.
Okay, awesome. Okay, here, thank you, Sheng. So here's the next one. This is from Janet. Can we change the location of the backups to a location on-prem rather than S3?
Yes, you can, for example, deploy a Minion on your data center, and you can ship because we only need S3 or NFS compatible storage, so you can just ship Longhorn to that Minion to their Minion object store. And in fact, in our instructions, we have here in the doc and the snapshot backup. here. We have a set up a local testing backup store. It's a test backup, so you probably want more actually about it. But the thing is, we have shipped a usable Minion YAML, which you can directly deploy and use it for your backup needs if you don't have access to S3.
Great, thank you. Okay, here's another question on backups. Is the backup ability exposed to users, or does it have to be managed by someone with cluster admin privileges?
Currently, Longhorn only managed by the admin. It's not as long as, but in fact, it's just as long as you have access to this project and this Longhorn namespace, you're able to access the UI of Longhorn. In the future, we are going to have more different role control on the different level of the user and accessibilities. But now everything is just designed for the admin for now.
Okay, cool. All right, here's the next one. Should RAID arrays be used, or are individual disks safer or better for any reason?
Oh, we know. In fact, Longhorn itself is more like a RAID, micro RAID controller, if you can think this, the Longhorn engine. And so we normally recommend that you just use individual disk, and you can if everything goes wrong, for example, say this replica somehow goes dead because that disk goes dead, the Longhorn will automatically rebuild. So individual disk is good enough.
Okay, awesome. All right, here's the next one. This is from David. At what point does the block device present on the node become a file system when presented to the pod using it?
So that is part deal with, not deal with, done by the Kubernetes driver. So whenever Kubernetes, the CSI driver internally has two calls. One is a mounted disk, one is an attached disk, another is a mounted disk in order for the pod to use. So for the attached disk, you can, it's a similar that here, in fact, in the UI, I can do attached disk. Say I create a new volume and I can attach it to any node. But this volume won't be used by the Kubernetes. It's more like this is the first step of Kubernetes. And the second step that is in the Kubernetes driver, the driver will see this block device and going to format it according to what's specified, the most likely just by default ext4. And then the driver will go to mount it on one local directory on the node, and Kubernetes will mount that local directory inside the pod to provide to the pod for the data storage. So the format that steps happens on the node in the Kubernetes, in the Longhorn's Kubernetes driver, more likely just CSI, Longhorn CSI plugin.
Okay, cool, thank you. All right, here's the next one. Are backups incremental or full each time? Is there a way to do incremental backups?
So backup are incremental. And in fact, if you see that I demonstrate the restoration is also through the disaster recovery volume. That restoration is also incremental. So we only copy what's changed from last snapshot in the case of backup, or what changed from the last backup in the case of restoration. So that makes things faster.
Cool, thank you. Okay, here's the next one. How do you restore from a backup?
Oh, okay. So you can, for example, just go here in the backup, you select the volume. I think it's a little bit slower before. Today, probably because of its Prime Day. And you can just select one backup, and you can just restore it, create, restored. And now it's listed in your Longhorn volumes.
Sweet. Okay, thank you. Here's the next one. When will Longhorn be GA?
We're targeting sometime this year, and our beta should be in a couple months, and GA we're targeting this year.
Okay, cool. So we are right at the the time that we had scheduled, but there are still maybe 15, maybe 20 questions left. There's a lot of questions. Do you want to keep going, Sheng? Or I'm willing to. Okay.
Yeah.
All right. Let's see.
Yeah. By the way, if you have other schedule and you can also always listen to the recording later, and it will be available in our YouTube channel.
That's right. Exactly. Okay. Oh, and we will email this recording to everyone too. So look for that in your email. Okay. Here's the next one. This is from Sten. Can backups be sent to S3 compatible block storage like Ceph Rados?
Yes. Yeah, I just show that as we can send out to the menu. As long as you are compatible with S3 API, we can send to you.
Okay, cool. All right, here's the here's the next one. Is it possible to start a pre-post backup script at the beginning or end of the backup, database in backup mode and back, for example?
Sorry, pre-post?
Yeah, this is from Frank. Is it possible to start a pre/post backup script at the beginning or end?
Oh, okay. Yeah. So it's basically I think what you want is the application level backup restore, right? So currently you can do that through the Longhorn API. But we haven't provided webhook or some kind of hook mechanism to do that yet. And also another thing we know we need to work on is we haven't have a Longhorn CLI yet. So currently you need to do a backup restore on the UI or through some Longhorn APIs. But after we got the Longhorn CLI ready, the things will be much easier.
Okay, great. Here's the next one. How is the data stored on physical disks?
The data was stored on physical disk in a form of a string of a sparse file. So we're using Linux sparse file to tell us what's the location of the data in that file, and we form that in a string like what you see here. In fact, I just take a few snapshots. And in fact, each snapshot will be a disk, a sparse file when we store in the Longhorn's data directory.
Okay, great. Let's see. What are the best use cases for Longhorn? Queues, databases, MySQL, Postgres, etc.
Yeah, I think as Longhorn is designed as a block storage. So normally, if you want to have a high performance storage, persistent storage, and you want to have your data backed up, and within building backup mechanism without configuring a lot of things to make it work, I think Longhorn will be a natural fit.
Awesome. Okay. Here's the next one. Is there any additional caching through Longhorn? Both Portworx and StorageOS claim to have additional caching that results in improved access speeds by simply using their solution, oftentimes seeing improved speeds with use cases like database or a Redis cluster.
Yeah, so currently Longhorn doesn't have any internal caching. The problem with caching is unless you are caching it in the, say, NVRAM, which you are not going to lose that data after you're powered off. Otherwise, you definitely have to be some data consistency between what you are written to the block device and what the real backend block device has. What's the data that's Longhorn or any storage stored. So currently Longhorn doesn't have a caching. We're probably going to introduce some caching mechanism in the future, but currently Longhorn is the crash consistent storage. After we introduce caching, we probably not going to keep that guarantee, because whatever in the cache is more likely in the memory. is probably going to be lost if the crash happens when the cache hasn't been cleaned and shipped to the backend. Yeah, but I can understand that in the many scenario, you probably can pay a small price for that, and in order to have a better throughput, especially when do a lot of small read writes. So it's also it's possible for Longhorn to introduce that, but it's not implemented at this point.
Okay, makes sense. Thank you. Here's the next one. Is there a size limit of a volume on Longhorn?
The size limit of the volume is basically the disk size. So we have we currently by default we're doing over provisioning is basically about 500%, so basically 5 times over provisioning. And if you have some concern over this, you can reduce this, or if you want to be more aggressive, you can increase this parameter. And but Longhorn itself, because currently the replicas are stored, the replica directly store the data. They are not crossing node or not crossing disk. So the limitation of this size, the real size, is the size of the disk. But if you say you have a volume and you want to create 1T or 100T volume, but you are not using that much, so Longhorn doesn't really care.
Got it.
But the real size limitation is the real size, like we see here. This is the actual size of the volume. This is limited by the disk size.
Oh, okay. Okay, here's the next one. This is from Rainer. How do we synchronize the data between the volumes of the app? Is this really the responsibility of the application?
Between the volumes, yeah, I think it's the responsibility of the applications. If you have any other ideas, or if you can specify what's your use case scenario, we can talk more about that.
Okay, cool. All right, here's the next one. Do you know the release date of the next of 0.6, 0.6?
Yeah, the 0.6 says we are expecting to release it in a month. Yeah, we have delayed it a little bit because the major refactoring work we have been working on. We want to make sure that it's stable, and also the upgrade will be a little bit challenged. So we have delayed a little bit. We're expecting to be released in a month.
Awesome. Okay, cool. Here's the next one. Longhorn works with cloud-based providers, not just local disk only, right? We have a mixed physical and cloud environment.
Yeah, so Longhorn can run as any place you have some storage available. Longhorn doesn't care that it's from local disk or it's from EBS or it's from cloud provider. In fact, this cluster I'm running right now is running inside the Linode. And previously we do demo from the DigitalOcean and the RKE. Everything was fine.
Okay, cool. Here's the next one. This is from Rainer. We have an application that runs one pod on each node. The first pod mounts a new Longhorn volume, but the second and third pod tries to mount the same volume of the first pod. How do we manage this correctly?
That is why you need to use the StatefulSet. The StatefulSet, we are going to create a new, of course, if your application is able to handle that, because there's application's responsibility to do the synchronization between the volumes, and you need to use the StatefulSet, and you use the volume claim template, and in the end, it will create one Longhorn volume per pod, and that's why we are going to have multiple volumes supplying your application. So that's what's the expecting behavior.
Okay. All right, here's the next one. Do you know the release date of a CLI for Longhorn?
Oh, we have that in our issue file, but we haven't started working on that. I think probably the release, one release or two release after next release.
Right. Okay. All right, here's the next one. Is it possible to send events to a logging system in case a node goes down or a volume is degraded or unhealthy?
So we're using the Kubernetes event log. So anything substantial will send to the event log. So you can just simply connect the Kubernetes event log with the source Longhorn volume controller. Oh, sorry, in factors, I think there's not a source here. Okay, I think there's some other, there's one column we are using to filter the filter this event log. But basically, if you have the event collected in the Longhorn system namespace, it should contain everything you can just collect.
Oh, okay.
Hello?
Cool. Oh yeah, I think you just broke up at the very end there, Sheng. But okay, anyway, here's the next question. This is from Sten. Yeah, I might have asked this already. I just want to make sure we get it in. Is RWX supported typically for block storage accesses RWO? How would Longhorn accommodate RWX?
RWX is not typically supported. It's very rarely supported by the block storage, and the Longhorn is the currently working on as in the RWO mode. The reason is, as I said before, the file system is building on top of block storage. You cannot change a block device without the file system knowing. Otherwise, that file system will think this block device is corrupted. And the end result is probably the file system, the OS, the Linux, we're going to remount the file system at the read-only. So that's why the block storage is almost always only attached to one node, and the distributed file system like NFS or GlassFS, FSS, those can cross the different nodes, and because they implemented a file system themselves, and they have some locking mechanism to solve the conflict between the operation of the different nodes. So in order for Longhorn to work as the RWX, we are still investigating a few solutions. The current one thing that definitely works is you can run an NFS provisioner with the Longhorn as the backend storage and expose the NFS. But one problem with that is, of course, NFS will become the single point of failure. And if that NFS node goes down, your storage will go down. So we're still working on, and we'll still see that if any other better way we can solve this. And also it's got something to do with the Kubernetes ability to deal with the down nodes. Frankly speaking, it's not very ideal. It's not deal very gracefully right now. So we're trying to work with the Kubernetes upstream to improve the situation.
I see. Okay, thank you. Also, there's a request to repeat the answer to one question because the sound went down, which was, is it possible to send events to a logging system in case the node goes down or the volume is degraded or unhealthy?
Yeah, so I think I just answered this. So for the event log, you can monitor the event log in the Longhorn system namespace, and you can see that, for example, this kind of you can watch for the certain events, like just say, let's see. In fact, I just sort by type. Oh, but this page is all normal. Okay, I have a warning here. Okay, this one replica goes down, and you can see this event is happening. It's types warning or type IRO. You can pick up those events from the Kubernetes event log, and you can see what's going on. And also, we have one open issue in our repo regarding to the notification system, and we're still looking into that.
Okay, cool. So we are at the last couple questions. So here's the next one. Are there data access speed related concerns when Longhorn is used? For example, abstraction for devices might introduce latency.
Normally block storage, if you have a solution like distributed block storage, is definitely not going to be as fast as your local hard drive accesses raw. But the ability of the distributed block storage provides is like HA as a backup, and also what you probably want to see that is, for example, Ceph, and even Ceph cannot reach the native speed after so many years, tens of years of development. But the thing is, the HA ability Ceph provides, and the HA and backup ability Longhorn provides, and can easily make up for that. And also, compared to the same class open source solutions, Longhorn is definitely on the class of fast.
Okay, cool. All right, here's the next one. If we use Longhorn for both storage persistence and backup of all volumes, then we don't need to use any other backup product for containers. Is that right?
Yeah, that is right. That is why we specifically want to have the Longhorn has a built-in backups. I know that's something. One thing about Ceph is Ceph doesn't really have an official built-in backup system, and you will definitely need to configure some third-party for that. But the Longhorn is everything is already bundled as a turnkey, just handled everything for you.
Awesome. Okay, just a couple more, and then I think we're right at the end. This is from Gunsik, who asks, what's the recommended network design for nodes to replicate? Is it just a single network interface in each? Is just a single network interface enough for each node?
Yeah, currently is this. We are looking to have a dedicated storage network building in Longhorn, but currently we are running on top of the Kubernetes overlay networking. The overlay networking overhead is very small right now. I think it's about low single-digit % overhead for the popular network solution for Kubernetes. So we think that is good enough for now. So at the first step, Longhorn, we want Longhorn to be very easy to use, very easy to deploy. And the next step, we are going to look into more details and how to optimize like the performance and the network usage, this kind of quality of service, this kind of topics.
Cool. Okay. All right, here's the next one. If we try to build a stateful set, the first pod mounts a volume correctly and the second gives a multi-attach error. Could you show how to build a stateful set with a Longhorn volume attached?
Oh yeah, you need to use the volume claim template. Let me see if I have some document here. In fact, this one probably have some. All right, I should have an example. Stateful set. This one. Yeah. No, here's this one. Okay, so this is the stateful set, and the volume claim template is only supported in the stateful set. You need to specify what the name is, and what is the access mode of the volume, and what's the storage class name. Of course, it's Longhorn here, and how much you request for storage. So using this volume claim template in your stateful set, Kubernetes will automatically create one volumes per pod, and as you scale up or scale up, and when you scale down, that PVC which created by the volume claim template will be detached from the pod, but whenever you scale up back again, that PVC will also still be used. So that is how you use the stateful set with the read-write once volumes.
Awesome. Okay, sweet. Thank you. Okay, last couple. This is from Frank. If a node is lost forever, how does the rebuild work?
So Longhorn doesn't really care about if the node is lost temporarily or forever, because the node lost is detected on the controller part. It's not determined by the Kubernetes. As I said, the data plane as Longhorn engine is completely separate from the managed plane. And the data plane once detected that because of a ping timeout, because of because a network connection didn't get a response, all these reasons will cause a replica to mark as error, and the manager will see that, and the manager will decide that, okay, so I see this replica is error, and I see that, okay, sometimes it seems one node is down, so I'm going to choose other node for the rebuild, and the replica will the manager will choose the node and start a replica on that, and ask the Longhorn engine to connect to that replica to start in the rebuilding process. So the node, if the node lost, we just going to choose any remaining node which still have the space for this volume, and starting the process there. It doesn't really. It's by design. It's handled very gracefully by the Longhorn engine and the Longhorn manager.
So cool. That's awesome. Thank you. Okay. Here's the next one. If the volume becomes unrecoverable, is there a way to drop existing replica and have Longhorn automatically rebuild a replica to recover the state, or is some sort of manual intervention needed?
Yeah. So if the you need to define that unrecoverable. So if you still have the, say, this Kubernetes cluster still there, and most likely you are going to still have this replica object stored in the Longhorn manager. And when that happens, you are going to see another option here called salvage. And the volume will be in the faulted state, like say, the volume doesn't really have any healthy replicas, but they will have a few replicas which are considered bad because of most likely network disconnection. And you can use the salvage options here just automatically, and the Longhorn will check which one is most likely contains the latest data, and start using that to search for your volume. If you're in the worst case scenario, if you lost your whole Longhorn cluster and lost your whole Kubernetes cluster, you still have a hard drive, and the hard drive, they have a directory, as I showed here. If this directory is still there, for any of the replicas, they're all the same. If the directory is still there, you can use this directory's content to manually recover volume from it. You can, because the Longhorn engine is designed to run without Longhorn manager, you can use the Longhorn engine just to run with this directory and expose the block device and then recover the data from that. Yeah, there was an issue opened in our GitHub and asking, say, if you have a replica data positioned somewhere on the node, they want to have ability just like Longhorn just automatically using, after choosing the location for the data, Longhorn can automatically build out volume of that. Yeah, we're still looking into that, but before that automatically full recovery happens, you can always just look into this directory and using the manual recovery with the Longhorn engine to do that. And this is definitely the worst possible scenario, because we are assuming that you lost your whole Longhorn cluster and probably the whole Kubernetes cluster, but you still have a way to recover your data.
So great. That's awesome. Thank you. Okay, this next one's from Ravi, who asked this a while ago. I'm sorry I missed this Ravi. He asked, is Longhorn tested with enterprise-grade applications and enterprise-grade storage, such as HPE 3PAR and EMC, etc.?
No, I think that's enterprise-grade storage. They're all dedicated boxes, and Longhorn is running as a cloud-native application, and yeah. So, and okay. So if you're going to test against HPE or EMC, you're going to, yeah, you really need some investment on that. You need to buy the box and set it up and all these things. And currently, we're more focused on how to get our software ready, stable, and performance better, and have the functionality users needed. So we haven't really looked into how we compare to the very expensive EMC HP level storage solutions there.
Okay, makes sense. All right, this is the last comment, actually. This is from Alexi, who says, "You both are the best. You answered so many questions. Thank you so much."
Thank you.
Yeah, I just wanted to put that out there. I hope I didn't miss any. Let me just run through one more time to make sure I didn't miss any questions. And there are a lot. And as Sheng said at the beginning, there is a Slack channel just for Project Longhorn. So if we miss your question or don't answer it for whatever reason, you can ask it there too. Let's see. Is there, okay, here are a couple more. Is there an item on the roadmap to link Longhorn instances between them in order to allow easy volume copy between Kubernetes clusters?
Yes, between Kubernetes clusters now you can do it now. We haven't fully automated it, but as this backup store is located on S3, and the one makes this backup is different from the currently I'm looking at. There's another. It's on the demos storage here. So basically, the communication between clusters we do it through our backup store, and you can take in the same backup store, so you can recover this volume either through the volume recovery feature or just restore the volume into a new cluster. It's already there.
Awesome. Okay, great. One more. It's from Frank. If a node is not available, Longhorn has rebuilt the volume and the node comes back. Does that mean Longhorn deletes the old data?
Yeah. So if the replica was bad for a certain period of time, and the Longhorn will automatically decide to delete it, and that is configurable. Oh, sorry. That's why it's when you do a create. Okay, I think that option was kind of hidden now. So for example, if the replica, the volume is still healthy, and there's one bad replica is there for about 20 minutes, and the Longhorn will decide to delete it. But if that bad replica is the last replica of the volume, Longhorn will not delete it because it may contains the last hope of recovering volume. So Longhorn will not do anything about that bad replica, even Longhorn think it's bad.
Okay. Okay, cool. And then I think this is the last one. Is Longhorn coming to Windows Server?
Currently no, because we're using Linux like sparse file and all this like C group, this kind of properties on the Linux, and we're totally building on top of Linux on the assumption of using Linux as the underlying operation system. So probably it's not really an easy thing for Longhorn to migrate and on the Windows node.
Okay, I gotcha. All right, well, there one more came in, so I spoke too soon. Is there going to be automatic placement of replicas in the next release? Right now, if a node goes down, there'll be multiple replicas on a node. After the node is back, they're not replaced.
Okay, that one, we then in the next release, we will introduce one feature called hard anti-affinity. And because now we're basically, if you know the anti-affinity, this word in the Kubernetes, it basically means we are trying to place pod on the different node, but if we cannot do that, we'll choose one existing node. That is a soft anti-affinity. The hard anti-affinity is that I will have to have our pod, or in this case, our replicas, placed on different node. Sorry. And if that cannot be satisfied, we are not going to rebuild that replica at all. We'll just wait for example, another node shows up, another condition so this node anti-affinity condition can be satisfied. So in fact, we have very lengthy discussion in one of our issues. Check. Let me see if I can find it. Oh yeah, this one. The issue 570. We have very lengthy discussing here and see that there's multiple stages we're going to do to address this issue, and you can look into this issue 570 for more details on what is going to be on the roadmap.
That's super great. That's awesome. Well, that was the last question, Sheng. Thank you so much. Anything else you want to say or leave us with?
Yeah, just we really appreciate all the feedback from the community. And as you can see that there's many features we added here, like this PVPC and identified WordPress and the recurring snapshot schedule and the last backup batch. And many features we show here is basically, it's really just coming from a suggestion of the community members. And we very welcome you to give the Longhorn a try and give us feedback and reach us in the Slack channel, forum, or raise the issues if you have any on the Longhorn/Longhorn. And every issue is raised here. We are going to respond it, and you can see our milestone and what currently we are working on. It's the 0.6 release, and what the issues and what things going to what things we are going to solve in the 0.6 release. And many users see their issues solving in 1 or 2 or 3 releases, and makes it different for them, and also it helps us a lot on improving the product. So definitely try give a Longhorn a try and let us know what you think. All right, that's it. Thank you.
Thank you. That's fantastic. And so yeah, everybody, this session was recorded. You'll get the recording in your email later today. It'll be posted on YouTube as well. So if you have any issues, please email me, matthew@rancher.com, or message us on Slack, and we will see you there. So thank you so much. Fantastic job.
All right, thank you, Matthew. Thank you, everyone, for coming.
Okay. Bye, everybody.
Bye.